Hello, everyone. My name is Gerard Gatch, and I'll be the moderator for today's webinar on the topic of novel benchtop FLPC, the Contichrom CUBE unit, ChromIQ software, its unique features for design, operation, and evaluation of continuous chromatography. We understand that you have limited time and came here to hear the content, so we'll forego formal introductions of our company until the end of the webinar. Just a few housekeeping notes, and we'll commence with the presentation. Today's seminar is approximately 30 minutes long, leaving time after the formal presentation to answer any questions you may have. Acknowledges. This presentation will give insights into ChromIQ software, which comes with unique features that make it particularly useful when designing, running, and evaluation of both single and twin column chromatography using the Contichrom CUBE instrument. The presentation will provide an overview of the software features and application cases. The presentation will cover these topics. Okay, today's presenter. Thomas Müller-Spath holds the position of Chief Technology Officer at YMC Chromicon, based in Zurich, Switzerland. Thomas is the inventor of more than 10 patents and has authored and co-authored more than 30 scientific articles and book chapters on continuous chromatography for biopharmaceuticals. Thomas frequently presents at international conferences as speaker and also co-chairs workshops on continuous chromatography. Please welcome Thomas Müller-Spath. Thomas?
Yeah, thanks, Gerard, for the kind introduction. Welcome also from my side to this presentation about ChromIQ and how it can be used for continuous chromatography. So first, I'd like to start with an overview about the continuous chromatography processes that can be run with the Contichrom twin column system. So first we have capture SMB, which is a process for affinity chromatography to improve capacity utilization and productivity. Here this process can increase productivity by a factor of 2 to 3 and save 40 to 60% of affinity resin costs. The process can be run with columns or membrane adsorbers, and the main application is purification of monoclonal antibodies. The system and the processes are at the status of GMP industrial implementation. MCSGP is a process for the polishing of biomolecules, but also of peptides and oligonucleotides. It is used in difficult purification cases where the product is accompanied by impurities in the front and in the back of the peak, and where product is caught in impure side fractions. In this case, the MCSGP process can typically improve the yield from 60 to 90% and improve solvent consumption by reducing it by 70%. Productivity can also be improved by up to a factor of 10-fold. And again, the main application is oligos and peptides and also biomolecules. This process is also in industrial implementation. These processes can be run on the benchtop scale in the Contichrom CUBE system, which is shown here. It's a twin column system. Both processes require 2 columns of the same type. And this system exists in 2 different versions, one version up to 36 ml per minute and the other one up to 100 ml per minute. The pressure rating is 100 bar, so about 1,500 psi. It has these functions of capture SMB, MCSGP, and the respective UV-based process control. Also, other processes can be run, such as enrich for impurity peak amplification and integrated batch chromatography, and also conventional single-column batch chromatography. I didn't mention these processes before because capture SMB and MCSGP are really the main applications in continuous chromatography. The system can use up to 18 buffers. It has 4 pumps, 2 on each module. There are 2 double UV detectors with single fixed wavelength, 280 and 300 nanometers. External UV detectors are also available to operate the system with different wavelengths, for example, 220 or 254 nanometers. The system also includes 2 connectivity cells, 1 pH sensor, and it's cold room compatible and has an external fraction collector. The ChromIQ is the operating software for designing and operation and evaluating processes on the Contichrom system. The Contichrom system is scalable to large scale and GMP scale, and we have done this a couple of times together with YMC Process Technologies in Devens in Massachusetts. Now, in order to run continuous chromatography processes, the system needs to support a number of configurations of the columns. So columns need to be operated in parallel or in interconnected mode, and in any order. So with column 1 being the upstream column, or with column 2 being the upstream column. There need to be detectors behind each column so that we can monitor the UV and conductivity signal at the outlet of each column. And we need to have inline dilution between the two columns. So whatever is coming out of column 1 needs to be conditioned before going into column 2. We at least need to have this option. It's required for the MCSGP process. We don't need it for the capture SMB process. These features have been presented in separate webinars, and they're available both on the small scale and on the large scale. So summarizing, the Contichrom system, the Contichrom CUBE system, is a system that has all-in-one process capabilities, and it's one unit really to address these various purification challenges in capture and polishing that you may encounter. So for difficult purifications, continuous chromatography is a good option. When the separation is very easy, then also single column chromatography can be a good option to run on this system. Also, the system can run integrated chromatography, which means two different chromatography modalities on one system. So the columns are different in that case. For example, anion exchange and cation exchange columns are run on the Contichrom system with inline dilution. Also, these processes have been presented in separate webinars. Okay, let's move on to the ChromIQ software. So the ChromIQ operating software consists of different modules. We first have a main program that is doing the run control and data display, and then we have modules for single column process design or integrated single column process design for the orthogonal polishing steps, for example. And then we have modules for twin column process design. And we have general modules like the evaluation center and system center. So these modules are standalone programs, and they can be carried out while the ChromIQ is running. So you can write methods while the system is running, or you can evaluate data while the Contichrom system is running. Most important are the programs for the design of the continuous chromatography processes. So we can get from single column to MCSGP in a few minutes by using the MCSGP wizard that provides a guided procedure to get from a single column run, a batch chromatogram, to an MCSGP method in essentially 15 minutes. The way it works is first you load a chromatogram of the batch run, you overlay the purity profile, then you select the product range and recycling fractions by drag and drop. So you select which region of the chromatogram is pure enough to take out and which region of the chromatogram you want to internally recycle to recover the product in the side fractions. So you do that by drag and drop, you set the desired washing and cleaning protocol, then you enable UV-based dynamic process control, and then you finalize the method by setting the number of cycles and the fractionation. So the advantage is you don't have to enter any pump settings except for the flow rates. You don't have to enter any valve settings to enable the different fluid paths of interconnected operation and parallel operation. All of that is done by the wizard. This just shows an expanded or a zoom of the previous first step of the MCSGP wizard, and shows also how you can enter purity data by importing the data from Excel and pasting them into this table. So it's really straightforward to move from single column chromatography to the MCSGP method. The drag and drop will allow you to select the regions for internal recycling and product extraction. So this is also done very user-friendly on the first page of the wizard. The UV-based control can be also enabled through the wizard. We have two options: one front control option, where we start collecting the product based on the UV threshold, and there's also the option to do tail control, which means we start to collect behind a certain behind the peak maximum when the signal has decreased by a certain percentage from this peak maximum. Also, the wizards allow for facility fit calculations by providing the process performance and the expected process performance data. So during finalization of the method, also the process performance data is shown in terms of productivity, buffer consumption, load, capacity utilization, steady state pool concentration, and others, so that with this data you can actually do a facility fit calculation. It's shown here for the example of capture SMB. So from the productivity you can calculate your large-scale scenarios, and you can come up with required column volumes with required buffer per day on the large scale. So all of this can be also done using the capture SMB wizard, or in the case of the MCSGP process, with the MCSGP wizard. Okay, so as mentioned, this has been shown in other webinars. The wizards have been presented there in detail. So now I would like to move on to specific features of the ChromIQ software that make it easy to run continuous chromatography. So we've talked about the design of the process now. Now we will talk about how to run those processes. So in the ChromIQ software, the main window shows the flow sheet with the two columns, and it also shows how the flow is going. So the active flow path is highlighted. So in this case, you can see there's a red highlighted fluid path going from this gradient pump here into the first column, then out of the first column into the second column, and then out into an outlet. And on its way into the second column, the stream is inline diluted, or has a connection to the inline dilution pump 2 here. Now this inline dilution pump is currently not active. You can see the flow rate here; it's shown 0, so it's not running. But if it was running, you could see it here. Now you can also see which on which position the inlet valves are and which buffer is connected to those pumps. Also, the pressures are shown here, and valve positions, and also on the left-hand side you can see the buffer levels are shown here. And I want to elaborate on this feature a little bit more later because it's very useful. We also have the option with the ChromIQ software to run the system with full manual control. So we can enable any pump, we can set any flow rate, we can run predefined operating positions, so columns in parallel, one column to the second column, vice versa, reverse flow. So we can do all of that and also record manually operated methods. After the procedure has started, you can also do on-the-fly changes. This means once we have started a method queue, the system center for manual control will be disabled, but it still will be possible to do some on-the-fly changes, which are usually or could be useful in continuous chromatography run operation. Now, in order to, before starting a run, this ChromIQ software has a number of other useful features. One is a software tool to support drop-to-drop connection during column mounting. So we can click on either column 1 or column 2, and the valves will switch to that position, and it's then possible to run a small flow rate to mount the columns, right? So in order to avoid air getting caught in the columns, we can enable a small flow on either side of the system to connect the columns and to have a drop-to-drop connection. Also, before starting a run, ChromIQ supports the priming of the buffer lines, and it will switch through all the buffers that are connected, so only the lines that are actually going to be used in the procedure, in the method queue, will be purged here. So it will ask you only to purge or to prime those lines that you will actually use. Okay, moving on to the buffer management. This is a very important feature for continuous chromatography, and you've seen it on the left-hand side of the flow sheet that I showed you initially. So once you click on that flow sheet here on the left side, assign buffers, you will get to this window that's shown here, and it will show which buffers are connected to the system. And based on the preset buffer levels that you have entered here, ChromIQ will then issue a warning if the buffer is running low. So it will show you you're running low on equilibration or adsorption buffer, and it will also stop the pumps if the buffer is empty. So it will enter a freeze mode once the buffers are empty. So this is very useful. The flow rates or the buffer consumption is actually calculated based on the flow rates that are used in the method that is run. So there's no online control of the level. It's just purely based on what you have entered here in terms of level and on the consumption of buffer that is estimated based on the flow rates that are in the method. So like this, if you're doing this, let's say in a disciplined way, and you enter the levels, you will never have a pump running dry because the system will stop before you get to that level. Also, with the buffer management, it's also possible to calculate the buffer consumption once the run has been operated, but I come to that later. Excuse me. So with ChromIQ, it's possible also to run methods in a queue. So this means, for example, in MCSGP, you can run a startup method, and then you can run different MCSGP runs with, for example, different flow rates to evaluate multiple steady states in one run. So this is very useful for screening of different steady states. For example, when you are doing a process characterization. Fractions are taken for every product dilution automatically, so you can run this overnight and come back in the morning and put all the samples in the analytics. And like this, you have the results from 3 runs basically at once. Of course, you can also include shutdown methods and cleaning methods into the queue. And like this, you can start in the morning with freshly equilibrated columns. It is also possible to, so ChromIQ also supports the use of multiple Contichrom systems to be controlled by one computer. So as you can see here, this is a setup that has been established at the Technical University of the Swiss Federal Institute of Technology, in Zurich. As the work has also been published. And here, 3 chromatography steps were run with 2 Contichrom CUBE systems, in conjunction with the perfusion bioreactor and at-line HPLC for quality monitoring. This was run for 21 days, and the feedback control concept was used to set flow rates and process parameters for the two Contichrom systems. So basically, ChromIQ supports crosstalk between systems that provide parameters for process control. Okay, this is just an overview, a slightly larger view of the setup shown before. Now I'd like to show you a few features of the evaluation center. So what you've seen before is the ChromIQ software and its the features useful for running continuous chromatography. And now we come to the evaluation post-run. So once you've run a continuous chromatography experiment, the one important thing you want to check is steady state, and to be able to judge if you have been reaching a constant product quality. For this, we have a number of features. So one is you can color the process with different colors by just pressing a single button. So if you have run a capture SMB run, you can just press a button, put colors for capture SMB, and it will show you the interconnected phases of capture SMB, and it will also show you the product eluids in red, interconnected phases in blue, so you can easily track the process and see how it has been operating. Same in MCSGP, it will show you the product elution phase and the overlapping, the internal recycling phases for the overlapping fractions in the front and in the back. Also, it's possible to do a cyclic overlay, so you can see if the process has actually reached steady state. In steady state, the chromatograms between or from the different cycles should not differ. So you can see here the product has reached steady state, the red area. In the red region, basically the chromatogram is the same, whereas the impurities here have not reached steady state in the front and in the back, which will not affect product quality, but it's just good to see if it has reached steady state, just for information. Good. Again, cyclic overlays can be done for both UVs and conductivities. So you can see here 5 cycles operated, and then is shown in sequence. And then by pressing a button, they are shown as a cyclic overlay. And again, graphical evaluation of cyclic steady state means if the chromatograms overlay or exactly match, essentially you expect to have a constant product quality from cycle to cycle, and it means that you have reached a steady state. Also, buffer consumption is important, or buffer consumption can be estimated using the evaluation center. So based on the flow rates, not only the consumption of an actually running experiment can be calculated, but also once the run is completed, we can calculate how much feed, how much buffer has been used, and where it went. So in the evaluation center, we click on a single button here, Compute Buffers. We get to a new window, and there it's shown us how much feed has been used, how much buffer has been used, to which outlet it went, so that we can see that also the sum of what came out of the system actually is matching what went in or what was loaded into the system. So with this, we can very quickly calculate the buffer consumption of our continuous chromatography run. Without this feature, it would become very difficult. We would have to take the number of cycles, we would have to take the different flow rates, multiply with the times, and it would be a very tedious work to calculate buffer consumption without this feature. Okay, so we can also do, apart from just showing selected run data, yeah, do the superimposition for not only, of course, for MCSGP, but also for capture SMB, as shown on these two figures here. Okay, the evaluation center also allows exporting graphs and data to the clipboard. So we can copy a graph figure to the clipboard, and actually only what is shown on this graph will also be exported. And we also can copy the data to the clipboard or to Excel. And finally, we can use the evaluation center to generate reports for the run that has been operated. We can select what information to show in the report, so we can generate customized reports, for example, to include integration and calibration data. So summarizing, ChromIQ offers a number of features which are very useful for continuous chromatography. So I just showed you snapshots of these features here. Generally, we get very good feedback on the software from various users, saying that it's very user-friendly and intuitive. So the main features are we have these wizards for the continuous process design. We have an active buffer management and buffer consumption calculation. We have tools for setting up continuous chromatography, the column switching tool, the buffer priming tool. We have method queuing for automated screening of a steady state. We have methods for automated cleaning, calibration, and qualification. I didn't elaborate on that too much, but these methods exist and also make it easy to quickly get results in an automated way without user interaction. And then we have finally graphical evaluation of cyclic steady state. We have superimposing the cycles to check if product quality is consistent from cycle to cycle. So with this, I'd like to thank you for your attention. And I think we have a few more closing remarks before we move on to the Q&A session.
Thank you very much, Thomas. That was a very clear and informative presentation. Since 1980, YMC has been a leader in chromatography, producing bench and prep scale HPLC and LPLC systems, packing resin, and columns. YMC is a global company with manufacturing and offices in over 10 countries. Just a reminder that there are other aspects of this topic that are covered in focus webinars and available on YouTube. Many of the topics that Thomas mentioned during the presentation are covered in detail in these on-demand webinars. Just go to YouTube and search on YMC Process Technologies. Okay, I'd like to bring Thomas back for the Q&A session. And we do have a number of questions. First question, does ChromIQ have the ability to monitor column efficiency over time?
Yeah, so we do have the evaluation center, right? And in the evaluation center, we can integrate areas of chromatograms. So basically, with this, we can then determine the area of the different peak elutions or the different interconnected loading stages over time. It's not automated, so you have to do this integration manually so far.
Very good. Next question. Can ChromIQ also run single column chromatography?
Yeah, so it can also do that. So there's a single column batch wizard. I didn't show it here on the slides. It's part of another webinar. But yes, also in that case, for single column chromatography, you can use a wizard that sets the valves then automatically, and you can just focus on the individual steps like equilibration, loading, recovery, regeneration.
Very good. Let's look at the next series of questions. Can methods in the cube be modified after the run has been started?
Yes, so to some extent we have the online configuration tool that allows these on-the-fly changes. So you can change after the run has been started your flow rates, and you can change also durations. You cannot change valve settings. One important thing you can do is to hold the current step. So, for example, if you see that your loading stage is not completed, you can press the hold button, and the run will continue with the currently set parameters. And then once you press the continue button, it will proceed with the method. Also, one important feature is in continuous chromatography, you can change the number of cycles that you want to run. So if you've reached steady state and you really see it graphically, then you can just say, okay, I just want to shorten this run by 1 or 2 cycles, and you adjust the number of cycles and then activate it. You don't need to run in steady state forever because it will not give you any new results.
Thank you, Thomas. Now for the next question. For MCSGP, inline dilution is required. Hence, how is this being controlled to make sure the conductivity is low enough prior to loading on CEX column?
Yeah, so there's no feedback control for the conductivity before it enters into the system. So that's not there on the Contichrom system. On the scale-up system, that's possible. So basically, this is done a priori by calculation. So when we are cutting the chromatogram using the drag and drop, as I've shown on one of the slides, then we know the conductivity or the percentage of buffer B, essentially, of the elution buffer at these cuts. So, and also we know the concentration of buffer at the gradient start. This we know from the single column run that has been used for MCSGP design. So then, based on the final concentration of buffer or buffer B, and on the starting concentration, we can calculate an inline dilution factor, and this is automatically done also in the MCSGP wizard, so that the flow rates are then set automatically to this dilution flow rate. Of course, it's also possible to confirm this. If you don't trust the wizard calculation, you can, but then you have to do a titration experiment to see if the dilution flow rate is sufficient. But usually it works very well.
Thank you. Next question, is reverse flow possible?
Yeah, just very briefly, yes, it's possible when the columns are operated in parallel mode. So then it's possible.
Okay, looking at the time and out of respect for everyone's time, we'll take 2 more questions. First one, what happens if there is an overpressure?
If there's an overpressure, then the system will enter a freeze mode, so which means that the pump will stop operating. You can set the overpressure levels in the software, so for the pumps individually. So whenever this level is reached, then the pumps will stop to prevent column damage.
Okay, and the final question, does this software scale to GMP production?
So the software itself is not capable for GMP manufacturing. On the large-scale system, there's a different operating software. However, there is a handover tool for getting from the cube to the large-scale system parameters.
Very good. Thomas, again, I would like to thank you for an excellent presentation. We're nearing the end of our time. You can continue to submit your questions and we will respond to them in writing. Thank you all for your questions and for your participation today. For those who have an immediate application or a question, you can reach out to Thomas at info@ymcpt.com. That's info@ymcpt.com. Again, in a short while, you'll be receiving a link to an archived version of this presentation and a link to associated reference documents. Please feel free to share these with your colleagues who couldn't attend today's live webinar. And once again, this is a reminder, this is one in a series of webinars, all of which you can find posted on our YouTube channel. Just search on YMC Process Technologies on YouTube. We'll end our session now. Thank you and have a good day.
Thank you. Have a good day. Bye-bye.